Hello guys, and welcome to the first tutorial on Salesforce for noobs. In this video I'm going to discuss how lazy loading works and why do we even need it. But first of all, before I explain that, in order for you to understand the need of lazy loading in Apex, you need to understand how static variables and static methods work behind the scenes. Okay, and I will explain those topics first, and then I will explain lazy loading. Okay, so if you have worked on Salesforce project or projects, there is a very high chance that you have encountered a giant class called constants. Okay, and this constants class probably contained a bunch of static methods or static variables, or maybe both of them. By the way, it's not very good practice to put all the constants in one constants class. It's best practice to segregate them into multiple other classes, but that's another topic, maybe for another video. So, yeah, let's get back to the main topic of this video. So, I have created constants class myself with just two variables. Okay. And probably you're asking yourself, why would you ever query S-objects in constants class? And answer is probably you wouldn't. But why I'm doing this here? Well, because I need to demonstrate how static variables work behind the scenes, and I need to use S-objects for it. And you will get it. You will understand why in a couple of minutes, I promise. Okay? So, let's start. What I have here, just two static variables, as I mentioned. So, account ID, just getting random account and getting ID from there. Okay, so, and then we have contact ID as well. Just querying random contact and getting ID from there. Okay, two simple variables. So let's open anonymous window. Okay, and I have this code copied. Account ID. Okay, so this is very obvious. I'm just trying to access account ID from constants class, this one, right? And now, what is this, right? So what this will give me? So this will give me the remaining query statements limit, which I have remained in this current execution context. Okay, so probably you are already familiar with the governor limits of Salesforce. So one of the limits is query statements. You can have maximum of 100 queries in one execution context. In synchronous context, 100, and in asynchronous context, you can have 200. Okay, so here, so when I click execute button, right, this code will be executed, right? So this is the first line of the execution context, which means limits should be fresh, and this will give me 100, because in synchronous context, as I mentioned, limit is 100. And then, so this will give me 100, then this will execute, which is just getting account ID, and one query is executed, and then this should give me 99 because one query was executed, right? Let's see. Execute. $100, then account ID, and 98. But why? Why is there 98? I thought we just retrieved account ID, which is just literally one query. And even though one query was executed, here is still 98. But why? Because that's how static variables work behind the scenes. In reality, 2 queries were executed. So, when you call a static variable in the class, not only that static variable which you are calling is calculated or loaded, but all other static variables will be loaded. All of them. Okay? So if I have here thousands of static variables, okay, and forget about doing queries, right? So let's say I have here some static variable, like another static variable, right, which is doing some calculation, right? And I'm calling another static variable, let's say account ID, right? Not only account ID will be loaded, but all the static variables will be loaded, okay? All of them, which are in this class. Okay, that's how static variables work behind the scenes, which is not very efficient because you need to access only one variable, but you are loading all of the static variables in the heap. Okay, and you have to be cautious with the limits in Salesforce, with heap size, also with a CPU time limit, because when you are calculating thousands of variables, it's gonna take maybe some CPU time. Especially when you are dealing with big projects, there are many processes, like many triggers are running, etc., and the limits should be used very cautiously. Okay, and besides limits issue, there is another problem. Let's say here I have another static variable which is trying to access setup object, okay, which is maybe trying to access maybe querying any setup object, okay, and let's say execution context is running under some user context, under some user, right? So executions which are run under user context and not in system mode. One example of it can be API call, maybe other external system calls our Salesforce org, and it's using some integration user on Salesforce side, and that integration user doesn't have access to setup objects. Okay, it doesn't have it, and that integration user in the execution context is trying to access probably, I don't know, account ID only. But as I mentioned, all of them will be loaded. So account ID will be loaded, contact ID will be loaded, and then it will try to access setup object, but it doesn't have access to view setup and configuration permission. So error will happen. Okay? That's another problem. Okay, so that's how static variables work behind the scenes. Now, how static methods work. Okay, let's see. Public static ID, case ID. What am I doing? Okay. Return select ID from case limit 1 ID. Okay. Let's see. Let's push it to the org first. Okay. Deployed successfully. Let's get rid of these comments. And let's call not case ID, but let's say get case ID, since it's method. Okay, 100, account ID, and 97. So I called static method, but static variables were also loaded, calculated. Okay, so that's how static variables work, and how static methods work is that if I basically when I call one static variable, as you already know, all of the static variables will be loaded, right? But once they are loaded, if I again try to access one of them or all of them in same execution context, they will not be recalculated. Okay? But static methods are recalculated every time you call them. Okay? So what I'm trying to say is that, let me demonstrate. Let me comment out this one. Or no, it's not interrupting me actually. So what I will do actually is, let me get again account ID. Account ID. So remember previous time it was 98, and now it should be 98 again, because so again, this line of code will try to access account ID, which will load all variables, because doesn't matter you call a static variable or static method, all of the variables will be loaded. Okay, so this will load both static variables, but it will not load static method, because static method is loaded only when it is called, okay, specifically. So this loads all the static variables, and this one will not try to recalculate again static variables, because it already has cached it, okay, in the execution context. Okay, so once I call it, query limit should be remained 98. Execute. As I said, 98, 98. Right? However, static methods are always recalculated, as I have mentioned. So if I call, so this should give me 100, of course. Then I'm trying to get case ID, and this should give me 99, because no, actually not 99, sorry, this should give me 97, right? Because I'm calling the method, which will consume one query statement, but also all the variables will be loaded. Okay, and it should give me 97 because 1, 2, and 3 queries. Then what's going to happen? That again I'm calling the case ID, get case ID. So one more query, and they will not be recalculated again because they were already calculated in the same execution context. They are already cached. They are already cached, okay? So it should, so here 97, and here only one query will be consumed, okay, because this is, so static methods do not cache things. They are calculated every time you call it, even if you call it like 20 times in same execution context, they will be recalculated 20 times, okay? So this will give me 96. If I do it again, 98, it will be 98. Okay, not 98, sorry, 95. I forgot how to count. Okay, let me prove it to you. And as you can see, okay, 100, the fresh start, 97, 96, 95. Okay, probably it's kinda difficult to process it at once, but I will summarize everything in the end of the video. Okay. Right, so that's how static methods end. So what are pros of static variables? Pros of static variables is that the main pro of the static variables is that they are being cached, and once they are loaded, they are not recalculated every time you call them from the same execution in the same execution context. Okay, they are calculated only once in execution context. But the con of it is that, so negative side is that even if you need just one static variable, all of them will be calculated. Doesn't matter if you call a static method or static variable, all of the static variables will be loaded. Okay. So good thing about static method is that if you call static variables, it is not loaded. Okay, static method will not get loaded magically by itself. If I have here another static method, okay, which will, I don't know, say get opportunity ID, okay, and if I call this method only, if I call get case ID, this will not be loaded. Okay, so only static variables and the method itself which I calling will be loaded. Okay, not other static methods. Other static methods will not be loaded. Okay, that's how static methods work. But static method is recalculated every time you call from same execution context. Okay, every time it will be recalculated, unlike static variables. Okay, so here is your summarization. I couldn't I couldn't be patient and wait until the end of the video to summarize. Now let's explain what is lazy loading, how to achieve it. So probably now you understand why do we need another mechanism which will avoid these issues. So issue of loading everything and issue of recalculating every time you are calling something. Okay, so let's write this thing: public static ID opportunity ID. Get, oh, what am I doing? Get if opportunity, I will explain what I'm writing. Okay, just let me finish. Select ID from opportunity limit 1 ID, return opportunity ID, and let's put your private set so nobody can modify besides this same class. Okay, so here I have getter and setter. In get, what I'm doing is I'm checking if opportunity ID is null. So it means that if it's not called yet, so nobody tried to access. If nobody had tried to access opportunity ID in this execution context, then it will be null at first, right? And it should be initialized at first. It should be calculated. It should be loaded, right? So query should happen. Otherwise, if it's not null, we'll directly go here, right? Return opportunity ID, right? Yeah, and then private set, which actually is for, so we are restricting other classes to modify value of opportunity ID. Okay, so even if I call opportunity ID, again, all static variables will be loaded. Okay. However, so this lazy loading is giving us possibility, is giving us the opportunity to access this variable, opportunity ID in this case, and cache it at the same time. Okay, so let me demonstrate it for you. Case ID, no. Let's replace this. Oh, what am I doing? Okay, so now let's think about it. What will be printed in the system debugs? In this system debugs. Okay, so firstly, when opportunity ID is called first, they will be, so this will be, both of them will be loaded, static variables will be loaded. Also, opportunity ID itself will be loaded, right? And query will be executed. So 97, there should be 97. And then, okay, so 97, and then again we're calling opportunity ID, and since this, as I mentioned, was cached, by the way, if we don't have here this if condition, and we are just directly returning this, then we will not achieve caching, okay? So it will be calculated every time. Every time we call opportunity ID from the same execution context, it will be recalculated. So in this case, we are using caching. So it has already the value because we called it here. Okay. So in this case, again, 97. And here again, 97. Doesn't matter how many times you call it. It will be again 97. Okay? So let's prove that point. Oh, I forgot to push this to the org. And execute. As I've said, 97, 97, 97, 97. Okay, so we solved the issue with lazy loading. Okay, so again, let's summarize. Static variables are loaded every time you call static variable or static method in the class. Okay, all static variables will be loaded. Okay. Static variables are cached. Okay, so the next time in the same execution context, if you call doesn't matter static variable or static method, static variables will not be recalculated. They will not be recalculated. Okay. Now static methods are not loaded when you call something else in the class. Okay, if you call other static method or static variable. Static methods are only calculated when you explicitly call them, okay? However, static methods are not getting cached. They are calculated every time you call it from in the same execution context. Every time they are recalculated. Now, with lazy loading, we are solving issues of static variables and static methods. So, in constants class, I would recommend to have lazy loading instead of them. Okay? Because here, when we are calling, when we are trying to access opportunity ID, it's going to be calculated first time. Okay, so it will be cached, and every other time when we are calling it, it will have already the value, so it will not be recalculated again and again and again. Okay, and if we have here multiple of them, if I have opportunity ID and again, if I have here account ID, so if I call opportunity ID, this will not be loaded, and let me prove it to you. Let me push first this to the org. Okay. So it should be now 99 only, right? Because we don't have static variables to load. So in this case, we are calling opportunity ID, and only this will be loaded. And as I mentioned, this will not be loaded. So here, let me write this too, right? 100, 99, 99, 99. Boom. Yeah, as I've said. So that is what lazy loading is doing. That is power of lazy loading, and that's a really good thing to use. Yeah, that's it for now. Thanks for watching, and I hope I explained it in an understandable way. This is kind of confusing topic, and you'll need some time to wrap your head around it, right, and to think about it, and maybe you'll do experiments on your own as well, right? But yeah, so that's really good thing to know and to implement in the projects. So yeah, that's it. Thanks for watching, and if you liked the video, then like the video, please, and subscribe to the channel, and press that bell button, and share it with your friends or colleagues which are in Salesforce ecosystem. And bye until next time.